So question 11, we're asked to show that sine 2x tan x is equal to 1 minus cos 2x, where x is between pi over 2 and 3 pi over 2. So this is one of the questions where you're going to have to be thinking about substituting in trigonomic expressions and then kind of rearranging them. But there's always a few kind of common clues that come up, but let's just have a look at the question. So you want to say sine 2x tan x is equal to 1 minus cos 2x. So basically, there's a left-hand side and a right-hand side, and you want to prove that they're equal. So basically what we want to do is kind of massage and change this side and change this side, or prove that this side then will equal that side. So we'll start off the left-hand side. Okay, can this be simplified at all? Well, sine 2x, that looks familiar. Well, if we go back up to our equation sheet, sine 2x, there's only one expression, becomes 2 sine x cos x. So sine 2x equals 2 sine x cos x. And what about tan x? Can that be simplified? Well, tan x is equal to sine x over cos x. That's one of the functions you just need to know off by heart. So what happens when we combine these two together and reconform them? So 2 sine x cos x multiplied by sine x over cos x. So this being from the tan and that being from the sine, sine 2x. Well, first of all, these are going to cancel. We have 2 sine x times sine x. So this is just going to become 2 sine squared x. So actually, left-hand side is now 2 sine squared x. Okay. So what about your right-hand side? Okay. So let's think about the right-hand side. Well, we have it here that 1 minus cos 2x. Okay, so we're going to be looking. We want it's going to be equal to a sine squared term, and then it's going to be a cos 2x term. So cos 2x here, and there's a sine squared term here. So it's going to be something to do with this. So cos 2x is equal to 1 minus 2 sine squared x. So if we move the 1 across, so this becomes cos 2x minus 1 equals minus 2 sine x 2. Then if we multiply everything by -1 to get rid of the negative, we have 2 sine x equals 1 minus cos 2x, which is actually what we were looking for in the beginning. So that's that there, and that's that there. So now we can see that we can put right hand side equals 1 minus cos 2x. So now we can see that the left-hand side, which is 2 sine 2x, is also equal to 1 minus cos 2x. So now you can make some sort of statement by saying right-hand side is equal to left-hand side as proven. So something like 2 sine squared x is equal to 1 minus cos 2x. So or So where are the marks in this question? They're saying there's a mark for substituting in 2 sine 2x and tan x. So there's a mark here. There's a mark for simplifying down to here. There's a mark for getting a suitable or substitution. So here. Then your last mark is for simplifying and communicating the result. So that's there. That's 4 to 4. Right, back down to the question. Okay, and the next question says, given that f of x is equal to sine 2x tan x, find f dash x. Okay, so what they're looking for you to do here is to use your result from part A, because obviously this would be quite hard to differentiate, but we know that actually it's equal to this, which is actually quite simple to differentiate. So f of x is equal to sine 2x minus, or tan x even, tan x, that's actually equal to 1 minus cos 2x, f of x. So f dash x is equal, well, you just got to differentiate these terms. So 1 differentiated becomes 0. Cos is going to go to, minus cos is going to go to positive sine, and then the 2 is going to be multiplied out to the front. So this becomes 2 sine 2x. So, and that's your final answer there. And the marks are for, they want to make sure that you link this to part A. So don't know if you need to state it explicitly, or you can just, if you just use a substitute, so from part A, so linking to part A and then doing the correct differentiation.